So this is going to be one we'll sell on eBay. It's a surplus set, and it's the fidelity. It's not. It's the Mustang CB3000, which is my favourite set to use the 002F Cybernet chassis. So it's come with a tired-looking mic, which I'm sure we can do something about, and it's come with a wide-in power lead, which I'm sure there's something we can do about that, like put a socket and a proper lead to it. So, because it's a unknown origin, I'm going to open it up first and make sure there's no shenanigans. Mark has already labelled it at the back, and I'll see what that label says in a moment. So it's Sunday, and I've got a lot of church services. I've done 2 this morning, got 1 this afternoon, so I've kind of got 20 minutes to make a start on this. So that screw's currently missing. What does Mark say? Oh, he says transmit power was 10 watts. Well, that needs addressing. It'll be dead. Yes, somebody's linked out the ballast resistor, which is very, very naughty. Spurious emissions. Those 10 watts aren't on 27 megs. I haven't got time to put it through the Spectrum Analyser to show you, but I have done before, and it's in the back catalogue. If you link that out, obviously you're going to kill the output transistor in the not too distant future. But, and legality aside, because obviously 4 watts maximum, the 10 watts isn't on 27 megs. You'll find that all the other ones we've seen, it brings it to 2 watts on 27 megs, and 4 watts plus will be on aircraft band on 112 megs. So it doesn't. Oh, look at all this power I'm doing. Yeah, but it's not on 27 megs. So there you go. That's the Wally thing to do, isn't it? So it won't be 10 watts on this test set, because Mark would have been testing it on a hobby type meter. But we'll see what it is doing. But I'm not putting the Spectrum Analyser on because I haven't got time. Right. I've got so many repairs in, I can't really be spending much time on my own sets. Right, power on. I'll put that in PA. And that one in extension speaker. It's a shame to see such a flagship radio done like this. Then it's got a diode and resistor. Does that mean it's been on a K40 mic at some time? Something else that will soon be going as well. I hope there's no other messings with. Right, so channel 20. Get the clipboard. Oh 16011327 Mustang CB, that's a C 3000. I think it's the 24th today. Alright, are we all ready for this? So here we are. I'll put picture in picture on. Power meter's on the 30 watt scale. 5 watts is there, 10 watts is there, 4 watts is there. So we'll key it up. It's actually doing 6.2 watts. On channel 40 it's doing 6.1. So we'll be doing a bit more than this because this test set is selective. And it's doing 6.5. So that is happening within the band of 24 to 33, I believe. Okay, to transmit current, go back to channel 20, 1.65 amps, low power, is 380 milliwatts. Deviation, for what it's worth on this test set, wow, is reading 3. And frequency, test set's not been on very long, certainly not been on half an hour, so we'll take this with a pinch of salt, but it won't be stupidly out. 2779118. That'll probably be about spot on when it warms up. I'll do VCO in a bit, but when I come back from church. So the meter on the front, when I key it up, does what? Oh, we need to go back into full power. Isn't far out. That's because it's been adjusted to take that into consideration. Meter lamp's working. Check PA. Testing 1 2, testing 1 2. Testing 1 2, testing 1 2, 1 2. Right. Back to normal. Plug the test instrument speaker in. We'll put 2779118 on the signal generator. That'll do. Right, we'll go back to... I can't do the transmitter tune-up because I've got to do that first. So we'll do the receiver. And we need to just check the cyanide first before. So let's look at the meter. We've got S9 on the signal and it is plus 30, so it's reading a bit fast. In fact, I need the actual figure, don't I? So let's get a figure. It is reading 30 microvolts for S9. Right, so we'll put this on the cyanide meter. These are sensitive sets usually. It's 0.29. For 10 dB it's 0.22, and for 20 it's 0.61. And for squelch to full, see where it is. Let's put the attenuator up on the inset picture. 3, 10 microvolts, 30, 100, never opens. It's a handy squelch. and let's see where it is at the sensitive end. That's well out of alignment. That actually wants some switch cleaner on it. I'm not doing them willy-nilly because I don't want to chase out the lubricant. Other seems alright. Right, set squelch. Switch the signal generator back on. Straight in. It's 0.3. So we'll get on with it. I'll start on the receive because of the limited time. I need to change that before I start doing the ballast resist. I don't want to be in transmit long, so I know I need to do the VCO as well. Right, receive. So first of all we need the signal generator showing the oscilloscope on there. 100 microvolts. Just like that. And let's make sure the detector is set right. Miles out. And that can affect the receive sensitivity and actually make it appear worse. So don't be surprised if we don't achieve the previous synod figures. Right, so now we'll go for those synod readings. Will it be worse? Will it be better? We'll go over to the... We will go over to the synod meter. Set it for about 4 dB. And we'll go through the front end. That was already spot on. That was already spot on. That was already spot on. A bit more signal now for the IFs. That was already spot on. That looked like it was. I don't think we're going to see any improvement, and it'll probably read worse. So we're now at 12 dB again. Let's see what we've got. Actually, we've got 0. I could say 0.295. I'm going to say 0.3. For 10 dB. .28. For 20 dB, 0.69. So you see they're marginally worse, but the detector's set right, so this is now correct. Right, S meter needs to read S9 for 100 microvolts. So we'll get that less generous. Oh, I think that's the squelch. So there we are now with that at 9, which is where it should be. The trouble is it's not going ever above that, so I might have to make it. This is probably why it's had to be adjusted wrongly. I'll just let it have a little bit more. So let's see what I've set it to. I've set it to 170 microvolts. No, I haven't. Yes, I have. No, I haven't. Yes, I have. So now it's going to be slightly lazy. Right. Squelch. Which I've now upset. So I've got squelch to full. So we want it to be stronger than that. It wants to open at 100 microvolts. We've now got on the signal generator. I'll show you the attenuator at 100. Drops into 30 and it's off. Drop on to 100, it's on. So now we'll do the test on minimum. Set the radio to squelch threshold. Signal generator back on. That didn't work out, let's try again. Point 3 still. The next thing I need to do to this is fit a ballast resistor to replace one that isn't there. So I'll come back to this in a few hours. Right, so that's installed the ballast resistor. Because it was totally missing, I do have the sleeving in stock, which is heat resistant, which is this kind of stuff. Right, let's power it back up. And hopefully we'll have something nearer 4 watts. So I don't need to put it on the Spectrum Analyser unless it fails on scratchy corner test. It's now doing 4.4 watts, so we can do a normal tune-up. I'll come back to the VCO. So we want peak, centre of the peak should I say, Remember, you've got a non-switchable Roger bleep on these. That wasn't warm enough. I said before, be very careful with polythene. If you know if these have got waxing like that, it's polythene. So you've got to be very, very careful. That's now 4.5 watts. Make sure there's no stretched coils. So that's not exactly perfect. 4.4 watts, and then we're going to adjust the power with the final one just here. And of course it's broken, isn't it? I'm hoping we can turn that round. That was predictable, wasn't it, folks? This is the very reason I started this channel, you know, in 2014, because I saw somebody saying about taking the ballast resistor out and all kinds of daft things to get more power out of these, and you don't get more power out of them, or it's very marginal if you do, because the power isn't on the frequency you expect. So the other side of it is fine, so we should be able to just put that in the other way round and not lose it in the works. Right, let's key up. So I wanted to hit peak and then go beyond. There we go. So there's 4 watts. So on channel 40 and 1, we'd also like it to do 4 watts. On channel 40, it's just less. On channel 1, it's spot on. So I'm going to actually just turn it little bit, so we're like 4.01. There we go. Channel 40 is now 4. Channel 1 is 4.02. Our transmit current now is 1.327, and low power will be something rubbish. It's not adjustable on these. You know what? It's 390 milliwatts. I'll take my words back. So it's actually where it was before. Brilliant. Right, we'll do the VCO. I'll just check it on this one again because we're now 2 hours plus later. Wallow. It's kind of 3, I think, on this. So what we had before it is. So I'll go to the test set behind me. And we'll see what we've got. 3.5. Wallow. Wallow. That should be right. Yeah, it's just that bit too high. Not stupidly high like we've seen some of these with 15. Check back with this one. Wallow. Why aren't we getting anything? Because we're on low power. One, two, I'll just retune this. Wallow. Right. So let's see what the meter does when we press transmit. It's actually in the centre of the red zone where it's supposed to be. But we're just going to give it a little tiny twiddle. Like that. Just going to get rid of this. So I'll need to put some heat shrink sleeving on that. Just so we can do the VCO, I'll do a quick tack together. And I don't think I've got the VCO setup instructions, so I'll have to go and fetch those. Right, so I've now printed off the service manual bit. VCO, and it's done on channel 1. So select channel 1. You'll see I've done the heat shrink tubing there and soldered that back together. We just want the multimeter. It's quite a wide set this. If you use this mobile, you need some right dashboard real estate. As ever, I can't remember whether these are a negative earth or a floating earth. So I'll tell you what, we'll put it to the case of a coil. Let's check we've got 12 volts, or 13.8 even, and it's the far side of this green capacitor here, which is capacitor 23. That's our VCO checkpoint. So it says with the thing on channel 1 and with it in receive, we should have 2 volts. We've got 2.7. Now we're going to have to adjust that coil, which somebody's put wax in, and that's exactly what I was telling you. Unless you're going to be very, very quick and not damage that coil, earwax removing drops will probably be the best way to do this. So that needs to go down. Like that. And on transmit, it wants us to also to be 2 volts, and if it isn't, we adjust it with trimmer capacitor CT1. We've actually got 0.2, which is ridiculous. Okay, back to receive. We're still at 2 because they are interactive to some extent. In transmit, we're at 2. Receive, we're in 2. Transmit, we're in 2. So, happy about that. Now, it doesn't tell you to do this, but I'm just going to check it on channel 40 that it's somewhere sensible. So, if I go to channel 40 from channel 1, it's 3.5, and really it's going to be wanting to be 4 or under. And that's our transmit. So that is perfect. That really needed sorting out. So although it worked on all 40 channels for me, if it had been in a cold or a hot temperature, then it would have dropped out. So that all that leaves is to put it on frequency. When we started off, it wasn't that far off. The gear hadn't warmed up. So let's see what we've got now. 2799, oh, on channel 40. $7912, so it's actually slightly high. Wrong tool. That's fine, we'll leave it at that. So there we go, that works very well. So I'm going to put, we're going to sell this one. I'm going to put the microphone through the dishwasher. Obviously going to take the works out of it. And the other thing is, we're going to have the glue gun onto this because it's only kind of hanging on by that one. See the other side. The other side's alright. But that looks really nice now, and now we've got all the proper parts back in and it's working as it should. I think we'll put some isopropyl alcohol on this side. Mr. Chippy's cleaned the case sides up. So, have I hidden my pen? So, VCO, I think it was something like 2.8 plus 0.8, wasn't it? And it was supposed to be 2 plus 2. So that was actually right, and it's 27.79129 I've left it at, which is slightly high, because they do drop with age. Deviation was 3, it's now 2.2 to 2.5 kilohertz. So the meter is now reading correct, it's the red zone, center red. So there we go, we're done. We're done on the air test. I just want to put some stuff on there to neaten it up. Right, so that's done the isopropyl alcohol. Now the specification for this, I just printed that off. It's supposed to be 0.5 volt for 20 dB synad. It's 0.69. So I think that was a bit fanciful. Very sensitive set. Good. Right, we'll start putting these lids on. Now I've got this side, which I said it's just held by one. I'm just going to pop some hot glue. Just to help stabilise that. You've got this corner missing just there. I know what we've not addressed. I'll finish this video, but this needs to be on a plug and socket, so I'll do that. I'd missed that. So I'll tell you what, we'll just put this on loosely. I want to get the video done, but before we flog it, it'll be on a plug and socket. I'll just put a couple of screws in for now, and I'll come back to that tomorrow. You know, if I spend another 40 minutes doing that, then the time window for doing the on the air test is gone. Especially as I've done 3 church services today. Right, power back on. It's come with a standard replacement mic, but I will run that through the dishwasher. Right, let's get it on the aerial instead of the test gear. It's another one which is not as tight as it ought to be. I'll take Mark's sticker off it as well. One on a Roger. 19 Roger. No, no Rogers today. Right, well there we go. So apart from the power lead, which I'll sort, that is done. Full 4 watts, nice receive. Thanks for watching.